Example 2 is asking us to determine the zeros of the following polynomial functions. So the difference is here that you actually have the y equals part instead of the 0 already replacing the y. So this actually is a cubic function here, and we can factor it to solve for the x-intercepts. So anytime we want to find an x-intercept, we're really letting x equal 0, which then means we're solving this mangled up cubic equation. Let's try that again. I wonder if I can pull this down a little bit closer. There we go. So let me try this. So 0 is equal to x cubed plus x squared minus 6x. Now again, we just always want to look for that common factor first, and I'm noticing every term has a factor of x. That gives us x times x squared plus x minus 6. Inside the bracket we have a nice little simple trinomial where we're looking for two numbers that will add to 1 and multiply to negative 6 from here and here. And two numbers that will do that for us are positive 3 and negative 2. They will multiply to negative 6 and add to 1. So because it's a simple trinomial, we can go directly to that factored form of x plus 3 and an x take away 2. So again, the only way that three things multiplied together will give us an answer of 0 is if one of those three things is actually equal to 0. So that gives us x equals 0, x plus 3 equals 0, which means x equals negative 3, and x minus 2 equals 0, which gives us x equals 2. Okay, and some of you will be able to skip the step in between and go directly to these three answers. The step in between being this one right here where you're setting the factor equal to 0, especially if you just have a 1x. If you need to put that step in though, by all means go ahead and do that. All right, part G, again, we want to find the x-intercepts for this function. Our x-intercepts will be where y equals 0. So we've got 0 equaling 16x to the 4 minus 81. So there's two terms here. I don't see anything common between them, but I do see that they are a difference of perfect squares. If I square root 16x to the 4, I get 4x squared. I square root 81 and we get 9. So we're going to get two brackets that are conjugates of each other. So they look the same except they have opposite signs. And now I'm noticing I have a sum of squares. This will not factor, but I have a second difference of squares here. 4x square rooted is 2x. A 9 square rooted is 3, so we're going to have a 2x minus 3 and a 2x plus 3. And then we can set each factor equal to 0. This one, whoops, let me undo that. There we go. So if we set each factor equal to 0 here, we're going to get a 4x squared plus 9 equaling 0. 4x squared equals negative 9. Divide both sides by 4, we get x squared equals negative 9 over 4. But if I try to square root that, x equals plus or minus the square root of negative 9 over 4, we will get an error because you cannot square root a negative number in the real number system. But we have two other x-intercepts here, two other zeros for this function. We get 2x equaling 3, x would equal 3 halves. And the other one then would be negative 3 halves. Just the same numbers, opposite sign. So there's two x-intercepts for this particular function, even though it's a quartic. Okay, now it's your turn to complete some questions here.